Okay. Okay. Thanks for joining, everybody. And as I just said previously, we're going to start the DevOps sessions from today. And this is the agenda for today. It is theory, some sort of strategic thing, because this is DevOps. When we talk about DevOps, it is also a big thing. Like when I say big thing, means the scope is pretty much very, very big. So we have to decide what you want to discuss, what will be mostly beneficial, and how you want to take it. Okay, because as I said, this is also I am to conduct on demand. Like what value is most to you? Many of you may know things, so does not need to repeat the same thing if you already know it, right? So I don't want to waste your time too, and rather I want to, it should be effective for everyone, right? I understand there will be some people also who won't be knowing everything or the basics, but so we'll balance it, okay? So that we'll not leave behind who are all freshers to DevOps. At the same time, we'll see that it is just not a killing and wastage of time who already know. So we'll keep some balance, okay? So coming to that, we'll talk some very, very basics. Maybe I won't call it basics though, but many time we know what are the tools, what are the technology, but sometimes we don't define the problem statement correctly, why it is, right? So that gives more clarity to it. So I thought my approach would be to address those first, then we'll go from there. Okay, so that's how it is, what I thought of. And I thought, let's define the problem first. We all are from software background, or IT background, I can say, right? So let me full screen this. Hope you can see my screen.
Yeah.
Okay. So when I say the problem statement, what exactly it is? If you see, this is a traditional business engineering and operation silos, which I spoke about sometimes back maybe. So when there is a project, any software project or IT project comes in, there are three separate business entity mostly involved. One is the business, who actually is responsible for the executive team, the business owners, and sometimes the business development. So they are kind of business roles, right? And there is also engineering team. So we have multiple projects, and we have multiple team and multiple people in the team, and they write the software, they write the code. There is project manager, there is a team lead, there is um, uh, kind of a lot of engineering specific roles are there, right? Then it comes to operation. I'm talking about a traditional. I'm not coming to DevOps right now. Typical calling what is the traditional operational model. So then we have DBAs, the database requirements for the project team. Then we have the infrastructure team who takes care of the infrastructure. Then obviously there is service team who take care of all the support and service. Right? So this is, uh, I'll appreciate if you can. Sorry, it's calling. Mute yourself, please. Okay. Okay. So this is what a traditional development environment and deployment looks like, right? So in this scenario, what is the problem? Which is, we have seen it since last maybe 20 years or 25 years. This is quite going on, and slowly it is changing, but this has been done traditionally. There is a very fundamental problem here, because I have seen, maybe I started my career almost 20 years back. you all, mostly all of you must have started your career at least 15, 20 years back, or maybe more than 30, some people maybe 30 years back too. So for us, this is common. But there was in today's scenario, there is a fundamental problem with this. What is the problem? So let's see, when the business had a requirement, like the business has a requirement, the executive team or the business owner, he comes up with a requirement. And with this traditional silos of teams, then when we actually release the product or deploy the product, it is, the time takes between sometimes 6 months to 1 year, maybe sometimes 1.5 years also. On an average, 8 months, right? So that time, that means today the business comes with an idea of business, and he asks the delivery engineering team to build it, and then it goes on building, then building the engineering team builds it, then it goes to operation, and then they deploy that. So then the user uses it, and then they give the feedback whether really it makes any sense or it has value, whether the business can get the initial value which it estimated or envisioned that this product or this service or this thought is going to give me business value. Sometimes it is not, and because the time between that now and the 8 months or 1 year, the whole thing may change. The services may change. There is maybe a computation came. Then there is maybe the different scenario of the society changed. And so after 1 year, maybe it does not have any value. So it's a loss. Today it makes sense maybe, but after 8 months or 1 year, it does not make any sense if the same product, because maybe the requirement changed also. Based on the current market scenario, we have a change in the requirement. But again, if you go to change that, then it takes us some time. So whole business sense is invalid. So the fundamental problem is usability of the product or service. As soon as we try to make it to available to the market. So that's obviously that is not there in this particular silos of teams. So it is called sometimes the feedback loop, or the user uses it and gives a feedback whether it makes sense for them. So that feedback loop it takes very, very long time to get a feedback loop, all the delivering the value, right? That is the fundamental problem, because everything related to business, if there is no business sense, there is no engineering team, there is no operation team, there is no value, right? I wanted to emphasize that. So what was the solution, right? So sometimes now, I'll go to my next slide. Then some people thought with Agile methodology, right? So they brought instead of waterfall model, then we got the Agile methodology. So then Agile was, up to some extent, it solved the problem. So because we all know that it is a test-driven development and it follows really solid engineering principles. And it is supposed to improve the success of the building software. Some of the problem, what just I mentioned, Agile actually solved some of the problems, because we had sprints, we had faster release cycles, and so on and so forth. I wanted to read that. We all know Agile possibly. I don't want to go deeper. But there is so I'll tell what Agile also could not solve. But these are some of the things what Agile solved and could not solve also. So what it could not solve, let's give an example. In Agile methodology, if you have attended your sprint meetings or the sprint and the daily stand-up, I'm sure we all must be attending it. You see that business gets involved very now and then. Almost every day, some business owner comes to the meeting and asks, hey, what is going on? He wants to get involved into our team meetings. Sometimes it does not make he is rather more involved. His time is important, right? But he has to be involved. That's because that is the Agile methodology. Then another thing is every day, some people I have seen, some companies, they take it as a instead of actually Agile in the stand-up meeting. Sometimes we try to just share our problems, share our experience, last what we did yesterday and today what we're going to do, and some problem, or if it should be maybe the whole meeting, maybe stand-up meeting should 10 to 15 minutes, it should be over, right? But some companies, some team, they what they do is they kind of taken as a status update meeting kind of thing. They mix both. So instead of doing a stand-up meeting, they do a status update meeting. So everybody gives what they did yesterday, they make a story, and what they're facing problem, and everybody takes 5 minutes, and it becomes half an hour meeting, or sometimes 45 minutes maybe. So everybody's time became kind of, out of 8 hours of day, 1 hour gone. With every day 1 hour gone. So that's one thing. I won't call it a disadvantage, but anyway, it depends upon team to team. But suppose a business owner every day spending 1 hour for a meeting, which is he could have been put into something else quite much valuable to him maybe. That's one thing. Then another thing is, if you see with Agile methodology, we have a release cycle, frequent release cycle, maybe 2 weeks. Every 2 weeks we have a release, or we have some new feature coming, right? So if you see the operation team, sometimes the operation team they don't like it. Why? The operation team's success actually measured in terms of stability, how the production and how stable the production environment is. That's what their measure of success. If the production environment is more stable, that is their success. If it is having bugs, there are a lot of issues and they have to fix it, then they don't want it. That's the operation teams, because then that means they're not doing their job. So the more number of releases are coming, the more number of bugs, number of configuration changes, number of engagements, and putting it. Suppose without DevOps, what they would do they would have all the administrators who want to deploy, they want to configure, everybody will be busy every 15 days. Again, fix, put it, then after 15 days, remove it, again put it. So which they don't like. And it is a very cumbersome job too. Nobody can just do it every 15 days. I have to redo the whole thing because there is a new release. So sometimes they oppose to the Agile methodology actually, because they know that it is more work for them. So if you see Agile, what it brings, obviously it brings some of the problem, it solves some of the problems, but it also brings some of the problem to the whole environment. Business owners, it demands time from the business owners, and it demands from the operation team that they should be involved more also. That is what, so these two people actually oppose. Maybe the engineering team is happy with Agile methodology, but these two people actually don't like it, business owner as well as operation. So that's what Agile brings in fact. And to solve that kind of problem, okay, DevOps actually came into being. That how we can take both these, some of the good things from Agile methodology and put some new things, what problem it brought with it, and how can we solve those problems so that everybody will be seamless and nobody will oppose to the Agile methodology. Okay, so DevOps is actually a way to evolve the operation and the business to work more closely with the engineering team so that they build a stable and trustworthy solution for a faster release. Okay, so because you see, ultimately everybody's goal in the company is nothing but a product should go to the user, right? And they should use it. So if it is not just business owner that they want to the product to go to the market, because if there is no product used by the user, there is no use of the operation team, there is no use of the engineering team. So everybody's goal is same. That is what is the motto of DevOps. If you remember, we all oldies, like who are all old timers in the industry, I used to say also, when I was a developer myself, I used to say, I didn't know much about the operation. In fact, I didn't know where it will be deployed. I was a Java developer. I didn't know how it will be deployed, how the high availability will work, how it will be scaled. I used to think that, okay, it's an operational thing. The administrators, they will deploy it, they will take care of the high availability, they will take care of the scalability, they'll take care of the auto scaling and so on and so forth. I'm not bothered. Neither I knew also really how it is done. In an interview, if somebody asks that, okay, how do you know how it will be built in the production environment? I don't know. So that used to be the scenario. In fact, today, some developers, they still don't know how the deployment will work, right? So DevOps bring solution to those kind of problems, because we want the engineering team involvement, because okay, here it is telling that I just made a point, the engineering team success is throughput, how fast they can build the solution and how much they can build. That is their success. That is the rate of success measured through throughput. Operation is measured through stability. So how they can combine both to bring more stable product instead of conflicting measures and conflicting thoughts, how both can be coming into the same platform and doing the job. That's about DevOps. So it is a statement I have just given, maybe a definition I like it to remember, and even if suggest you to remember this. It is a cross-functional community of practice dedicated to study of building, evolving, and operating rapidly changing, secure, resilient system at scale. So that is what is the DevOps motto. And it is just a community. So it is not about the team, it is not about development, it's not about operation, but it is a sense of coming into a platform and making a practice for changing the culture to build a secure, resilient, scaled system. Okay, so let's see what is continuous delivery then. We define now DevOps. Now in that DevOps, there is something, sometimes it interchangeably we call it CI/CD, right? CI, continuous integration, continuous deployment, or continuous delivery. CI/CD. So let's understand what is continuous delivery. So anybody can tell me, first of all, really before going there, if you know continuous delivery and continuous deployment, what is the difference? I just wanted to, let's see, instead of I speak, I want to know who is doing, I stopped sharing. So if you can tell me, please, just who knows what is the difference between continuous delivery and continuous deployment? What is the difference? Please raise your hand, or maybe on the chat write. Again, I want to see who is writing what. So this is a kind of not test, but I want to see who knows really, so that I can actually know who is actually already know DevOps, who does not. So that will give me a kind of knowledge also, so that I can address individually. Okay, I didn't see Harsal wrote something that he is having echo. Anybody, you are also feeling the same echo?
No.
Let me see if I can use. Okay, people, nobody wrote. Or please hands up if you know that, or if anybody can speak.
So continuous deployment is basically we are deploying our application to a pipelining and deploying our software automatically to either the staging server or the production server, something like, to like Puppet or something, where you automate your infrastructure to be automatically deployed when you are pushing a new code. Basically, it is a sync between your Git, your what are the
Let's not talk
changes you.
about tools. No, no tools. I just wanted the concepts.
I don't. To me, I don't see much difference between delivery and deployment. It has a lot more common similarities. Whereas deployment, I see it as a way of automating your deployment through pipelining.
Okay. So anybody else want to try? Give it a shot.
This is central. This is like more of continuous integration is where you have your code and then as and when you commit it, you kind of build it with your whatever version that you have in your subversion or like whatever version that you have, and then make sure your code is not breaking anything. And continuous delivery is again like the next step of it, where you can automate your deployment, probably to QA or UAT environments, where whatever you build, it creates a deployable and then it's pushed into the corresponding environment. And
Okay.
for production, you can have like a.
Yeah, good. So yeah, you everybody knows almost, but just to clarify for this. So I'll start with an example, maybe then it will be clear. So let's see, we all are using mobile. We have our app store. Just giving a small example, right? So sometimes we have our
I
mobile.
see some.
Sorry, can you hear me?
Yeah,
I mean, I believe some network bandwidth.
Can you hear me, guys?
Yes.
yeah, we can.
Yes.
Okay.
Yes.
Okay. So is it echoing still? Because I'm using the.
No.
No.
Okay, fine. Okay. So as I was just talking that we all are having mobile phones and we are using mobile apps, right? So I have an update coming every 15 days or so. So once I say that install my update, maybe if you have a deep configuration of your mobile that, okay, automatically the update should be deployed or applied, then it will automatic update happens. But otherwise, what you do is sometimes you see, go to the App Store and install the update, right? You do that. We all do that, right? So here, there is two things here, delivery and deployment. So the app is delivered to your app store by the development team every 15 days continuously, or with their sprint cycle, right? So that is called continuous delivery. Whether you deploy that or not, that is a different process. That is after delivery, you deploy it. So you deploy based, sometimes you automate it. I have automated in my mobile, I have automated deployment so that as soon as there is a update happens, it deploys to my end. This is my end device, right? Like that, because this is a production environment, like when it is used by the user, it is a production. So that means my mobile is the environment where it will be deployed finally, right? So that can be automated, which I have done. or anybody can manually deploy it also. So if it is automated, then it's called continuous deployment. And the developer team, maybe the app team, which is developing that application, they are every 15 days or every sprint cycle, they're delivering the software, which is the end software, which is ready for the end product, which is ready for deployment, right? So that is continuous delivery. Is it clear?
Yep.
That's the difference. More. That's why, Sanjit, you said that both are same, but yes, both are same, of course, related, but there is some difference also, that unless it is deployed, the delivered software is not deployed at the client place or at the production, then that is just sitting at a maybe a artifactory's place or repository. Artifacts are just saved somewhere, right? Artifactory server, you must have heard of it.
Yes, yes, yes.
So that is being delivered to the Artifactory server. That is delivered. So it is a continuous delivery happening. But once it's taken, that maybe a jar file is built and it is taken to deploy, maybe at a container environment, getting a container or getting directly putting that into an application server, that is continuous deployment.
So I have a question here. Both of these, will you consider them as an engineering process, or only you will see CD as an engineering process, whereas CD means deployment as an engineering process, whereas delivery is just a bridging between these two?
So I'll call it a CI/CD process or DevOps process rather than telling that it is engineering, because in a DevOps environment, I don't differentiate between this is called engineering job or this is the silos of mentality or culture that should go away. Actually, it should go away, and nobody now should consider that okay, this is engineering activity and
It's deployment.
development or that is operation activity. I don't know. So I call it whole thing is part of the whole DevOps culture. There should be a cultural shift should happen to be successful in a DevOps culture. Okay. So let's not call it as engineering effort or operation effort. It is a collective effort. Depends. So that brings the autonomous, giving more autonomous to individuals, giving more freedom to individuals, rather than telling that, hey, you are responsible for that and you are responsible for that. That should be slowly. It is coming. I believe many companies are giving more autonomous, more freedom to individuals to take the thing what they're comfortable, and at the same time there is a risk of shared responsibilities, nobody's responsibility also, right? Sometimes you think that it's a shared responsibility. Some people said, why should I do that? It is not mine. So nobody responsibility also. And that is a risk we carry. But at the same, as long as people understand that it is a collective effort, if the team wants to be successful, if the organization wants to be successful, it is a collective effort, and I do without waiting for somebody tell me what to do, I should do it. If that is there, then this will be a success. Okay. So let's go back to our presentation. Do you see the slides?
Yep.
Okay. I have two screens, so actually sometimes I don't know. This is pretty. I'll just. Why it is not? I'm not seeing which one is this sharing. Just give me 1 minute, please.
What is continuous delivery?
Sometimes it is coming in this screen, sometimes it is going to other screen. I don't know why. Okay. So continuous delivery, right? So there is a DevOps. We call the guru of DevOps, Jez Hamba. Have you heard his name?
Now I think we can see the desktop.
Oh, I don't know what is happening. So let me have my both the screens to one. Okay, remote the
Before actually we were able to see it, but now we can see the beautiful fall color.
okay. Hopefully it is clear now.
Yes.
Yep.
Okay. Is it you are seeing only one page or the whole page?
Just one.
Okay.
I think you are seeing the whole page. So might be you need to click on that use site flow on the top. That
no,
should just.
as long as you are seeing the slide, that should be fine. Okay, so what is continuous delivery? This is the definition given by Jez Humble, and he actually was served with, I think, US government, I think. He served as a DevOps CTO or something. So he gave this definition that continuous delivery is nothing but the ability to get changes, features, configuration changes, bug fixes, experiments into production or into the hands of users safely and quickly in a sustainable way. So it is like, you see, the into the production or into the hand of users. Okay. Safely, quickly, in a sustainable way. So in terms of mobile, it is obviously given to the user. And in terms of in data center, it is given into the production. Okay, so in a sustainable way, safely and quickly. That's the definition they has given for continuous delivery. Okay, so which is obvious. I don't have to explain it. Now, why continuous delivery? So it is not about releasing every. Nowadays, in fact, we see that people say nowadays we are multiple delivery happening per day or every minute. Sometimes a lot of companies they claim. So it is not about that, but it is about how we make every release painless, or it is a low risk affair or low risk event. Previously, I know that when there used to be a release, I used to work for Sun Microsystems, and there was a release, 4 days we will not go home, right? And we'll be sitting there in the office. And I am sure you also must be having that experience. If there is a release, I'm not going home, because there will be food, lunch, dinner, and 2 days work there and sleep also in the office. And once everything release is success, it is installed and configured at the customer places, and there is like happen and tested, no bugs or something, then we go back home. As long as it is not tested that, okay, sometimes something gone wrong, or roll back. Then another 2 days, maybe rolling back to the previous. So that was a very big event and risky event also, right? More bigger the event is, more riskier it is. So it is continuous delivery is nothing but making the risk lower and lower and painless. That's about continuous delivery. It is not about how many releases you have per day. Reduce time to market, increasing the quality of the software, making it more stable, and the reducing the cost and reducing the employee satisfaction as well as the customer satisfaction. So this is all about continuous delivery. So these are all achieved, then we are doing good. I'll go faster. So keys to continuous delivery, what it makes a successful continuous delivery is reduce the number of features for each release and minimizing the shock to the user. A lot of features came at a time is not good, right? So I'm not able to decide whether really I want it or not. So make the every release smaller with less number of features. changes approach releasing software from an event to a non-event as seamlessly as any other thing. Then avoid high risk and expensive deployments. Have the rollback plan, as I said. If you don't have a rollback, if anything gone wrong, how automated rollbacks would happen, that should be there. And build health checks. That means during build itself, we should check whether there is a bug or not. Or during development sometimes. In fact, I'll tell you what is pair programming also nowadays. They have, that is a part of checking the health, reducing the risk also. That means during development also somebody is watching you if you're not making bugs, and that is also comes in the cycle during development. Pair programming is part of it, right? That means one guy is coding, another guy is watching, because if he cannot make a mistake, then and there itself it will be fixed. So that is a cycle during development itself. So I'll come back to that. Microservices, we all know, if not at least heard of it, what is microservices based application development. And where it is started, I will tell you that. So automation and automation movement, bringing infrastructure as code using like tools like Terraform, which is infrastructure as code. We are doing a lot of things. Many people are using Terraform nowadays to build their infrastructure by coding. Developers build infrastructure. So, and configuration tools like Chef, Puppet, Ansible, and so on and so forth. So by using these kind of approach, we can have a successful continuous delivery approach. And let's talk about what is continuous integration. So sometimes continuous integration means we think that, oh, Jenkins, by default, we know that continuous integration tool, Jenkins, right? So it is not about just building a Jenkins pipeline or putting the code into Jenkins. That is not continuous integration. The philosophy behind continuous integration is bringing bugless software at the very low level during development only. That means we want to catch any bug or security issues during development itself. That is a part of continuous integration. So that when everybody bring together the software into one place, and when you just check in your code, that time itself will check whether automated fashion that if there is any bug or fixes available for your code. So that's why it is continuously integrated. CI is not about Jenkins, but it is, if you are building a lot of branches also, that is not good for continuous integration. So sometimes every user, they have a branch, or every feature they have a branch. So that is that means more number of branches in the GitHub or Bitbucket we are using. The trunk is the master, okay? The master branch is the trunk. And how many branches you have, that, and you are coding, your code goes to each branch, then obviously when it goes to master, it goes to dev, and then master, and final build happens, it becomes more difficult, and sometimes we may not actually get the bug easily during integration. So a less number of branches are always good. It's going ahead. So this is some history I want to give here. I said this is a bit theory today, but this gives us good base actually, why and how. Okay, so that's why I thought of giving this history of it. In 2011, this is the statistics of Amazon development. This is, you see, it is comparative to today, it is nothing, but that time it was obviously high. Okay, you see here like 11.6 seconds. There was the mean time between developments, right? And so on and so forth. All this data is available publicly. I gave this slide from public. So today you see that it is manifold data, and the statistics will be unimaginably high. But this was in 2011. Okay, so going back again, another interesting slide. This is what in 2002, actually Jeff Bezos started kind of the DevOps journey in Amazon. So this was later was given to every employee. It was by Jeff Bezos. If you read it, it tells exactly what they are today, and it is in 2002. This Jeff Bezos sent it. All teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through this interface. There will be no other form of interposed communications allowed. No direct linking, no direct reads from another team, data source, no shared memory model, no backdoor whatsoever. The only communication allowed is via service interface over the network. And it does not matter what technology you use, whether HTTP, Corba, PubSub, or some custom protocols, doesn't matter, but he didn't care, right? All service interface without exception must be designed from ground up to be externalizable. That is to say, the team must plan, design to be able to expose the interface to developers in the outside world, no exception. Anyone who does not do this will be fired. Thank you. So this is this is also publicly available. So if you see that they started, this is actually the start of DevOps. Their main, even today they follow it. You build it, you have coding, you did the coding, you build it, you deploy it, and you support it. That's the philosophy of Amazon also today. Every team, they are responsible for everything. That means the team which develops the code, they are responsible for deploying it, they are responsible for support also. So like there will be not separate people who will be responsible for the support. And that means there is no separate silos culture, right? So that's what I think that the DevOps journey started in Amazon, and everybody started following that same. And they have another philosophy called two pizza team. I'm sure you must have heard of it. Two pizza team. That means they want to have a small team of around 8 to 9 people. So what is two pizza team is, if you buy 2 pizzas, the number of people can eat these 2 pizzas should be in one team. So typically it can vary from 6 to 8 people or 9 people, like 2 pizza they can eat. So that is what it should be, the team size. And that's part of DevOps culture. That means the smaller team, the better the management, the better they build communication between them, and the better build better software. So that is part of DevOps culture too. So this is the theory. I had some around 12 pages, and now we'll go back to our technology stuffs. Any questions? Please go ahead if you have any questions. Okay. I understand we all know theories, but we're here for practical practice. Okay. So this is, I wanted to give a quick overview of what a CI/CD pipeline looks like. I have just given a CI/CD implementation of microservices using containers. Okay. The top one I have given, this is the pipeline. Can you see my pointer?
Yes.
Okay, so the source code repository, leftmost. Then we have a build environment, then the artifact repository. Then, because this is container specific, so I'm talking about, then is a Docker container repository or Docker image repository. And finally, the deployment environment. So this is the pipeline looks like. And down, I have actually mapped each stage to different tools. Okay, like in which section, which tools can be used. So sometimes this is called a tool chain, pipeline tool chain. That means it is a chain of tools to be used in every stage, from taking one stage to another stage. Okay, so we'll see about those tools one by one. That's why I tell it will be a non-ending journey we'll have. It is not going to end soon, very soon, because we have to learn a lot of tools. But at least we'll learn. Okay, so what my plan is, I want your suggestion too. Unless that, without that, we cannot do a lot of things. I am planning to do one project on Java, where we'll take from beginning to end, like creating a small project on Java and taking the Java code from source code to deployment through all these stages using different tools. That is one. Because I want everybody should be benefited, so that is one we'll do. Then again, another we'll do is same like .NET platform guys. I'm sure there will be some .NET guys. So .NET environment also will create a small .NET project, and we'll take the same approach, same different tools related to .NET environment. Finally, we'll deploy maybe on a Azure platform or Azure environment. So that will be, I'm talking about again in terms of cloud. Wherever possible, we'll use our own tools in our own environment, but ultimately we'll always try to deploy into a cloud, okay? Because we cannot afford to have paid, and we need a huge, if you want to put all the tools in cloud, we don't have that paid, I don't have at least that paid subscription then I have to pay a lot, which I don't have. Then that's why for the tools, intermediate tools, we'll use our own laptop. But I have created a source code repository myself. We can use that. And finally, with our own free subscription of cloud, we'll see how we can deploy to that. But intermediate tools, we are going to use our own laptop, because we cannot have these tools, all the tools on the cloud itself. Then it will cost everybody. If you want to spend, you are fine to and go ahead and do that. But that is not necessary, because you have your own laptop where you can do it. Okay. And then another thing is, if you are a front-end developer or Node.js developer where you want to use some JavaScript, Node.js. Do anybody Node.js developer here? And to see it, please, if you can hands up, please. Any Node.js developer?
Yes, my name is Pragya.
Yep.
Yeah.
You are a Node.js developer?
Yeah, actually, I'm a front-end developer.
Okay. Okay. That's why. So you which front-end tool you like, front-end language, and
Yeah, Angular.
Angular.
Angular. Okay. Yeah, Angular 6 and 7.
Okay, Angular. Okay. So then we'll also do a small project of Angular also. Okay. And how that can be containerized, and Angular with Node.js maybe that can be containerized and deployed into a container environment. Okay.
Okay.
And we'll do all in terms of microservices. We'll not do any traditional web application development, because I'm sure we all learn we should move forward rather than going back, right?
Yep.
So I will not focus on traditional web applications or web servers like or application servers like WebSphere or WebLogic or .NET
Java,
IS
Tomcat.
server, Tomcat. We'll use Tomcat sometimes using microservices, but we'll take all the examples in terms of microservices. Sounds good?
Yep.
Okay. And I was thinking another ways. How many are Java, please, hands up? 1, 2, 3. Anybody else? Java. So, okay. So who is not from development background? I want to know. Who is not? Hands down, please. And I just want who is not from development background. So Pradeep and Nirav, if I'm understanding correct, you're not from development background. Sujit, Sanjit. I'm not Dave. Akhila Sahu, okay. So Harsal, you're not from development also? That's no problem, ma'am. See, I just wanted to understand so that I can focus on, please don't feel other way. Nothing is good or bad, like we all know that. So, yep, so 1, 2, 3, 4, 5. So I don't expect you to know. Let's build our, do some homework before we really go ahead. I don't expect you to understand the complete development, but those who are all not from development, at least I expect them to understand how they're built, how the compilation happens. So that's what I expect. You don't need to know how the code is written, what is the syntax. I don't care, you don't care. But at least I expect that if you know how it is built, what are the tools used, if you maybe you have to spend some time understanding that. I'll take here though, but that's what initially we'll do. Sometimes I'll also help you guys. That's why I saw with different variations in our colleagues here, so our team. So we will take everybody's interest. So, and we'll learn basics of Java. Maybe sometimes I'll not go and teach how Java is written, but I'll tell you how it is compiled, okay, or how it is built. So similarly, who are not .NET, I will not tell how .NET is written, but I'll tell you how .NET is compiled or how it is built. Okay, same thing with Node.js. Obviously, there is Node.js, we don't build it, but at least how it runs. These are the main 3 languages we'll target, so that we all feel comfortable. Okay, and for all developers, okay, for them also some work. They should come with those knowledge that you may not be doing currently the deployment. You may not be doing, you may be only doing coding now of a module, but in a microservices, how it is deployed, that's what you should know. How a microservices is deployed, how a container is created. Obviously, I'll keep a session for containers, how a Docker container, that fundamentals, and I'll not go deeper into Docker container, but I'll cover the basics of Docker and how a code, or how in terms of Java, if you take, how a jar file is taken and a container is built around it. I'll cover that. Similarly, for .NET people, I want to take a DLL file, and once you build it, and we'll put it in that we'll containerize that, and we'll deploy it. Similarly, a Node.js application will containerize that and we'll deploy it. And finally, we'll see how we'll take the whole pipeline, build of a pipeline. So, as being said, I'm not okay. So let me show my screen. Give me 1 minute, please. Any question or any suggestion?
Hey Panja, this is Dilip here.
Yep.
Okay. So as we introduced initially, right? I am basically a techno-functional manager and I do technical work on C, C++, Shell Script, and Oracle. Okay, and Agile hands-on, also Scrum Master. I worked as a Scrum Master. So how this is going to be help me, for this DevOps? I'm very new to DevOps. I don't know anything on DevOps. Is
You
that
are
fruitful?
you may not be, but you said you are a Scrum Master, right? So you
No, techno-functional manager. I do technical delivery, technical code. Okay, on C, C++, Shell Script, and Oracle,
okay.
PL/SQL. Okay.
Okay, so I understand. I got it. So I can see still it is valuable to you how it is. Many time, in fact, I had a project myself where there was a only requirement was configuration changes. That means, the people or developers didn't write any code, new code for that application. The whole code is actually written just changing your configuration of the end product and putting that into deployment, changing the configuration. Like you are a data, you were telling that you are into Oracle, right?
Yes.
So how there is a aspect of DevOps also towards databases. Okay, how DevOps and database can be together, and maybe that if you can, we can explore. Maybe I'll tell more on it later. How DevOps and databases can be combined, and how it will help you in your career too.
But the same thing is in cloud also, right? If you go to Amazon cloud, there is a database, right?
See, DevOps is nothing different than cloud. I'm not. This is a culture. We are talking about a culture. We are not talking about technology, or we are not talking about any tool. DevOps is a culture, and that's what we are going to learn. So it is. So if you see my discussion, that's why the fundamental I covered just now. Cloud is not DevOps, or DevOps is not cloud, but they are also the same. But how we implement DevOps in cloud, that makes the difference. Okay, how you implement DevOps culture to your cloud. That's what we're going to learn, right?
Okay.
So it is not. I don't know why you said that it is cloud and this is not DevOps. What is the comparison, by the way? There is no comparison. Cloud is a platform, right?
Yeah. Cloud is a platform, and that's what we are using all these tools in the DevOps. We can use on the cloud also, right?
It's kind of a process also. DevOps, if you see that, it's a process, right? Or a culture to bring together the dev environment and the deployment environment, all the operation environments together to have a faster release cycle, a faster deployment cycle. That's the main aim of DevOps, right?
Yeah, I understand that, Panja. My main question was, do we build C, C++ or Oracle code on the tool and deploy those?
Yeah, of course. And it can apply to anything. In fact, see, why not? When you deploy, you compile a C program or C++ program, obviously we create the exe file, right?
That's correct, yes.
How that exe file will be deployed in any deployment environment, that's part of the process. And you can see that which tool will be suitable. And you have to find which tool will be suitable for that. So, okay, and how maybe in fact, it can be integrated into your database, right? So even if that can have a pipeline. So for every software cycle, how DevOps can be applied, that's what we are going to learn. That's why I took the different examples. In fact, because I thought many were not really nowadays, many people are not working on C, C++. That's why I didn't take that example. But yes, that can be also an example. Why I take .NET and Java and Node.js, because more of projects are coming nowadays, right? More of people are working those. C++. I am a C++ guy, by the way. I started my career.
Thank you.
So, and that's why, and a whole Solaris. I was a Solaris developer, right, in Sun. So it was in C and C++. Even if all the commands, Solaris commands, I was part of that team who wrote Solaris commands, like, and the DLL files. So, or the, not DLL files, but shared object files, .sos, right? So I was a C, but I don't think if nowadays also people are writing it. But thanks to bring my knowledge that you are working.
It's evergreen.
Oh, yeah.
C++ is evergreen.
Okay, so we'll do that and we'll finalize. And now for just this information, I'm going to use GitLab. I found this is cheaper. So gitlab.com. I have set up, okay, a Git environment here so that we'll be writing code and deploy to this environment. Deploy means we'll uploading or check out our code to GitLab, okay? And I have created a user here. So, okay. So this is, I created a project also, community learn project, and we'll create 3 different repository for the 3 different projects. One is for Java, another is for .NET, another is for um, um, Node.js, and now, as you said, maybe C or C++ also. Okay.
I'll follow you and we'll create one more project on C++. I will do
No,
that.
this is one project and we can have multiple repositories.
Okay.
So in this also we can have 4 repositories. There is nothing wrong. Okay. And we can do it. So I once I set it up properly, I'll send you guys invite, and so that you can also join. And whoever interested, I have made it public. Okay. This is, I think right now it is private. I'll see being now, I cannot give you big open.cloud domain username, but I think you can get your own if I make it public. So at least you can have a with your use, I think, email ID. I request you to create one username in gitlab.com. It is free to create a username. So that once you create, I'll send you individually invite so that you will be able to code commit to this. Okay. And maybe this will be more collaborative because I want to work as a virtual team of whatever, how many people today? 19 people or 20 people, 20, another 2 is not joined. So I am sensing 25 people, I think. So we'll make a virtual team of 25 people, including me, and we'll write a small program or maybe create a project. And as you wish, if you want to donate code, you are free, or mostly I'll be writing. Okay. And if you want to do and develop something, you can contribute, you are welcome. But mostly I'll be writing the code and for the demo. And if you have to make a really project, we can do that, a small project, in fact, and you want to, but the whole project will be mine, the code will be mine ultimately. Okay.
Oh, that's okay, man.
just kidding. So okay, so that's what is my approach, and suggestions are welcome. Any more thing, because I thought of 8:42 now, so I thought of covering this today, the basics, and I have set up the Git repo, the GitLab repo. And once you please send me individually email ID. My email ID I'm typing here, pnayak@bigopen.cloud. Okay. So this is my email ID.
So you want to type email here in this group chat, or I can send some.
Okay, in the WhatsApp chat I'll write. Okay. So, or I already wrote in this chat my email ID. Did I write privately? Oh, sorry. So it was gone to hostel privately. It will be fun, I think, because we'll be working still virtual team, okay? And we'll experience also how the collaboration happens in a DevOps world, okay? So that you can write some code, you can send, even if one line, if you are changing how you check out the code using Git, and you will also go through the pipeline, how will access the pipeline. At least you will have a practical experience of executing a pipeline and deploying it to a, finally, I'm planning actually to deploy into a Kubernetes environment.
Great.
Sorry?
Nothing. I said great.
Yeah, so finally we'll also have experience of a, I will not be able to take the details of Kubernetes, but who knows, I might plan also for that once this is over. Kubernetes completely, so which is hot in the market. So we can also do that if time permits. God knows what happens, but at least I will be creating a Kubernetes environment to deploy our containers. This is what I can do. So that at least you will have that experience of deploying to Kubernetes using DevOps pipeline. Okay, so that's being said, that's all for today. And please send me independently email with your email ID after you finish creating a username in gitlab.com. Sounds good?
You want the username or the email or email?
You have, Pancha, you have all the email ID where you are sending email, right?
I have in my group around more than 60 people. I don't want to create everybody's. You know, that's a good big work for me, and I cannot go and create users for you all. Okay, please, you help yourself create a user with your own email ID and send me email ID that you have created it.
Oh, okay.
Okay, because it will be a big work for me.
What is the tool you mentioned? Can you come up again?
GitLab.com.
Okay.
Let me write it here in the chat. It's free, so. Okay, GitLab.com. So we'll be using the tool GitLab. Also, we'll. Okay, before we end this, I want to make some something requirement for our project work. Requirement is you should have a strong, powerful laptop, because I'm going to create a GitLab runner in your laptop, and that will be a virtual machine to be created in a laptop using VirtualBox. So please install VirtualBox also, okay, in your laptop. If you have heard of VirtualBox.
Is that okay with Oracle VM?
I think VirtualBox is from Oracle. So
yeah, that I don't know whether other VirtualBox is there or not. I used Oracle VM VirtualBox.
Oracle VM VirtualBox.
And that's the same one. I mean, Oracle VM, I also have the same. It is.
By the way, VirtualBox was from Sun Microsystems, so it is our product, and
yeah,
Oracle took it. So I'm compatible with VirtualBox. It was Sun Microsystems VirtualBox. Now it is Oracle.
Yeah, it is same. It is Oracle VM VirtualBox Manager. That's what it says. So I think Dilip what he said is correct. You can use that.
Yeah, you can use it. And
Oracle also took over Zoom. That you know.
Really?
Yeah.
Okay.
In cloud.
Wow. Okay.
Collaboration.
So this is.
Maybe Panchaleshwar, you can show everyone your VM manager so that.
No, so I just see go to virtual.
Okay.
What is? Is it? What is this? No, this is not. Sorry. VirtualBox search. Okay. Search VirtualBox.
Yes. Yeah. Go to that. Yeah. That is that. Yeah. This is the one I think we should.
Okay. This is not .com org. So okay, this one it's free. Okay, it's from Oracle. So 6.1, I expect all of you to please install. That's why in my chart I said that you should have the admin permission in your laptop to be able to install it, because it will change some of the network things. What I'll do is maybe I'll next time once or we have time, maybe I can take you through how to install VirtualBox. Okay, in your laptop.
I think it is simple. I mean,
for you maybe, see, because you see, I don't take anything simple, okay, because who you have not used it is difficult for you. So simple. So for you and me, maybe simple. I don't have to take it granted, but who does not have, who you have not done it. Suppose then you don't know what network changes it will be difficult for you. So I don't have to take that as a kind of yes from everybody that it is not difficult. But yes, next time what I'll do is I'll, so quickly if I can do it also, let's see here, when you go to VirtualBox downloads, for Windows host and OS X host, for me it will be OS X host, and both will be same anyway. So we'll go to OS X host, I'll download it. Purposefully I have removed it actually, so that I can reinstall it in front of everybody. So I just download it. VirtualBox, I'm going to install it. Okay, so just run the file. You can do it in your laptop too, same thing, just run it, double click once we download Windows users. And just double click. This is a bit different in Mac, but Windows, it should be just here directly, continue.
Your screen is not visible.
Is it not yet? Is it?
No, it's the instruction page of VirtualBox, but the
Okay.
compiler which you are running to
Okay.
install.
So I didn't share my whole screen actually. I shared the application. Sorry, I didn't share my desktop actually. Okay, is it visible now?
Yeah.
Let me go back. Okay. So when I downloaded this, okay, I downloaded, and then in my download folder I have it. Okay, so I just run it, and this came, and just double click, continue, and in Windows user you'll see this one anyway. Okay, from here it will be same, continue and install, and give your administrator password. Possibly it will ask. If you are already administrator, it won't ask. So it will be writing the files, and it will make some changes to your network also. Okay, because it will be creating a new network interface for you. Okay, in your laptop.
Punch, so, what exactly this VirtualBox is like, similar to VM or?
See, instead of cloud, and that's why I have to save your money. Don't, by not using cloud for the basic work. So what you can do is, because this will, your laptop, it will create a virtual environment. Okay, and
okay,
can create a local VM to work for. Like you can, okay, you can create n number of local VMs you want according to the power of your system. If if your laptop is too much powerful, you can even create 20 VMs, the whole environment you can create. You see, this is my VMs. How many VMs I'm running?
Right.
Okay. So, I'm running the whole Kubernetes cluster in my laptop.
Got it.
Okay. So because mine is 32 gig RAM, my laptop is having 32 gig RAM and 6-core processor, 2 terabyte SSD. So it's very powerful. So yeah, that's why I said if you have a powerful laptop, the whole environment you can create in your laptop itself. You don't have to go anywhere in the cloud to learn it. Okay. But we'll create some other things what is required in the local machine, but we'll use the ultimately cloud because that's our motto to learn cloud, right? So we'll deploy into cloud. That's what we'll do. Okay.
Okay.
So please install this VirtualBox, and you'll find plenty of videos how to install VirtualBox also on YouTube. If you cannot, or if you cannot, still next time I can help you out. Sounds good? Any more? Okay, so we'll stop here today, and this is what I try to achieve today, and we'll see all of you next time.
Just one last question. So instead of VirtualBox, if we want to use the cloud, still we can do that, right?
But yes, you can if you want to. But you know what?
Because I do get like around 150 credits in my company subscription for Azure every month. So if you need to create like multiple VM, I can, but.
No, I think still we can. Okay, then we'll do both the things actually. Because we can have 3 VMs in our Amazon cloud also, right? 3 VMs, we can have 8 gig, sorry, like 1 gig each, right?
Okay.
So we'll see also, we'll see both the way. But I wanted to give it so that you don't have to just to practice some of the DevOps technology, like you don't have to log in every time, you know, to the cloud. Locally, you have a laptop, suppose without network, because VirtualBox will give you the opportunity to work without network also. Like you don't need the internet to work with VirtualBox, right? So.
All right. Yeah, but I'm using my company laptop, so that's why I thought instead of installing, because you.
I don't expect you to break your law rule. Whatever you are comfortable, you do it. And if you want to create on cloud, definitely you can do that. And that's what is actually we're learning for. And you can do that. What we'll do is we'll create a VM on your on everybody's cloud. In fact, you have now all of you. I think we have AWS account. So we'll create a Git runner on AWS platform also. And
okay.
So, okay, so that once it can run on, once we run the pipeline, it actually execution will happen on the cloud. That we can do also.
Thank you.
All the way so that, see, my intention is to make you enabled so that you know what are the options, what are the ways, basically taking away the fear also. That is my main intention, okay? And you have all the opportunity to do it. In fact, if one cloud does not allow, you can use another cloud. A lot of clouds are giving every different number of VMs. So we can actually, like we can create 3 VMs on AWS, we can create another 3 on Azure, maybe another 3 and 2. Oracle gives 2. We can, so we can have 5, 6 VMs running at a time, and we can have a true multi-cloud and hybrid cloud because we are running 1 VM on the laptop also. So we can have a hybrid cloud as well as multi-cloud environment.
Okay, thank you so much.
Okay. Yeah, so that's all for today. Okay.
Thank you.
Thank you.
Thank you.
Thank you.